So good morning to all of you. So just who will go for summary of the previous class. So yesterday we discussed about thermistors, right? And pyrometers. In the pyrometers, three types: total radiation pyrometer, optical pyrometer, infrared pyrometer. In that we discussed only one radiation pyrometer only, right? So now thermistor is nothing but thermal plus resistor. Just I will go for 2 or 3 minutes. I'll give you a brief summary of the previous class. Thermistor, thermal plus resistor is nothing but thermistor. So here this thermistor having voice is not audible. Somebody said voice is not audible. Audible? Okay, now it is okay. It is okay. Number lateral to 326. It is audible or not? 326. 326. Audible or not? No. Anybody? It is audible? Yes. Number 326 better you can check your is there any wrong with you? Number 326. Okay, right. See here in this thermistor, positive temperature coefficient and negative temperature coefficient. That is minus 250 degrees centigrade to 500 degrees centigrade, the range of the temperatures. With the help of the thermistor, you can measure the temperatures. In the negative temperature coefficient, that means the resistance will decrease with the increase of the temperature. With the increase of temperature, 1 minute. So negative temperature coefficients, when the resistance will increase, there will be a decrease in the temperature. Whereas in the case of the positive, here the increase of temperature is proportional to the increase in resistance. That means here in the negative, that means from 0 minus 5 degrees centigrade minus 10 degrees centigrade of increase of temperature in negative. So there will be a decrease in the resistance. And in the case of 0, 5 degrees centigrade, 10 degrees centigrade, 50 degrees centigrade, 75 degrees centigrade, in that increase in the temperature, there will be the increase in the resistance of the material. So here these thermistors are made up of with some oxides of manganese, nickel, cobalt, and we discussed so many alloys, zinc, tin, like that, copper. So there are so many materials which exhibits the property of that is which exhibits the property of that means whenever it is exposed to the temperature, the resistance will be developed. And then these thermistors actually applications are widely used, maybe in the household appliances we discussed, right, in ovens, right, in refrigerators, and also, for example, in 3D printing in industrial processing industry to measure the temperature. And the main advantage of thermistor is it responds quickly. That means the output of the thermistor, you can get the measurement of temperature of a particular body or a substance, can get the fast response. This is about the thermistor. And then we also discussed about the bimetallic sensors, right? Two metals having different temperature coefficients, and when it is exposed to the temperature, the expansion of the two metals differs. Thereby, we can use for on and off devices. Example, I told to you that automatic iron box. That means we can shut off the power and we can on the power. So that is automatically it will happen with the help of this materials. The expansion coefficient differs from the two metals. And then next we discussed about radiation pyrometer. Radiation pyrometer is also one pyrometer is also used, that is also used to measure the temperature of a particular body, that is a non-contact type of a device, that is not in contact, non-contact type of device. This pyrometer means it absorbs the radiations emitted from an object. So these radiations intendedly develops the heat, so thereby we can measure the temperature of that radiation emitted of a particular of a body. Now, today we are going to discussing about the pyrometers. The next, the other two pyrometers, that is optical pyrometer and infrared pyrometer. So in the optical pyrometers, in the figure, if you see clearly, uh, here it consists of here a filter is there, and a screen, and another objective lens. It is there, objective lens. This is absorption skin. Here the temperature emitting body, or temperature emitting body means that means it is emitting the radiation from the source. Here in this especially optical pyrometer, it works on the principle of a monochromatic source of light. So that means from a body, radiation is emitted means that means a radiation having a heat, that is it is having a temperature, the temperature varies. Here, body to body, here for example, so my face is visible to all of you. So how can you see that visible? Here my body, my face is emitting radiations. So the radiations, emitting radiations only, you can observe some portion here is black and this is blue and this is like that. You can go for variation. That means each color of an object emits the radiations different. So each and every radiation having some particular temperature. So here in this temperature source, this is a temperature source. Here this is a temperature source, right? Uh, so we have to measure the temperature of that a body. See, optical pyrometer is a non-contact type of device. We have to place near to the object or a body whose temperature has to be measured. That object emitting a light, and it is focused on, then if you observe here, it is focusing on the objective lens. It is focusing whatever the radiations emitted from a body, that means hot radiations, so that it is focused to fall on the objective lens. Here this eyepiece, with the help of the eyepiece we have to adjust such that it will focus on the lens. Here, and another one, here this is a filament. All of you see this is a filament. Here the filter is there between the eyepiece and the filament, and here the absorption screen is placed in between the filament and the objective lens. Here, see here another some circuitry diagram is there. Here rheostat is there, battery is there, PMCC meter. The PMCC meter is nothing but a permanent magnet coil meter. It is a multimeter. Maybe it measures the voltmeter or ammeter. And then if you observe clearly at here, then when the radiations falls on the objective lens, this absorption skill, it absorbs the radiations. It absorbs the radiations, and then actually it absorbs the radiations, and then it falls on the filament. It falls on the filament. It falls on the filament. So here filter is there. The filter means uh, to the eyepiece. Here from the to the eyepiece, it uh, that means it filters the unwanted radiation to the eyepiece. Unwanted radiations, unwanted. That means which is harmful. So here that is so. That's why here we arranged a filter. And then here, if the here, if you observe clearly, this is dark, and this is disappearing, and this is bright. Here, when the filament, this is the filament. If the filament is dark, means the current passing through the filament is low. That means here we have to adjust the rheostat. We have to adjust the rheostat, so thereby the current varies. So here, the if the filament is appears dark, then the current passing through the filament is low. And then again we have to adjust the rheostat, thereby the current passing through the filament is exact. These are all the things we have to observe with the help of the eyepiece. And then here the filament is completely disappear. The meaning of that is, all of you understand here, the meaning of this one is, when the current flows through the filament is low, that means when the filament disappears, that means the temperature source, that is the source of the temperature, is less. Here is less, that means less. When it is exact means, here the filament temperature is disappears. That means here what we have to understand, that the filament disappears means, whatever the filament brightness will be equal to the temperature. That means this temperature, the, that is the radiation emitted by the source is, both are same, both are same. Here the current passing through the filament is exact. So here that current passing we have to adjust with the help of the rheostat, and then with the help of the eyepiece you can observe the filament is disappear. That means the meaning of that one is, that is, uh, the temperature, that is the source emitting radiations, is correct, it is matched with the filament disappears. When the filament disappears, the meaning of this, it means here it is equivalent to the brightness of the source emitting radiation. And then when it is here, if the current passing through the filament is high means, then the filament it appears bright. The meaning of that means, that is the meaning of appearance of bright of the filament is, here the source, uh, the brightness is more. That means it is too hot. That indicates it is too hot. So that is the thing. That means it is hotter to the temperature. So that means here the hotter to the temperature of the body. That means it is wrong. So here, when the current is passing through the filament is exact, that means then the filament disappears. The meaning of that is indicates whatever the temperature, the source emitting radiations will be matched with the that filament disappear. That means both the radiations are same. Both the radiations are same. So so here we are adjusting that current, right? With the help of the rheostat. Whenever the current passing through the filament is exact, the filament disappears. Then we have to go for that particular current. We have to calibrate in terms of the temperature of that particular body. So that is the thing. Anybody can understand? Anybody any doubts in this optical pyrometer? Optical pyrometer. Optical pyrometer. వింటున్నారా లేదమ్మా? So here, purpose of a filter, use of rheostat, formula are given. So latency 39 formula, no formula. Just it is a calibration. A purpose of a filter. Here the purpose of the filter means, here when the radiations, here the screen absorbed the screen and then it falls on the filament, right? So here, when you observe through the eyepiece, somewhat the radiations is very harmful means, so with the help of the filter, you can filter that one. That means unwanted radiations, it will not send to the eyepiece. Unwanted. So what is the meaning of the filter? Just filter. Explain. Filter means, for example, the filter, it meaning filter. It filter, for example, water filter is there. It that means it filter the water. That means whatever the dust particles, it will remove. The filter remove the dust particles from the water. So same here. Like filter is also it. That means it removed the harmful radiations reaching to the eyepiece. So that means, and then next, how to measure the temperature, right? That is a good thing. So what I told to you that here, current is calibrating into the temperature of that particular body. See here, when you observe here, the current passing through here, the current here we are adjusting with the help of the rheostat. Here we are adjusting the current with the help of the rheostat. So thereby the current sends this the current sends that means here see that filament and these radiations will match together. That means here the current when the rheostat adjusted, the current varies. So here the current what happens when the current sends, the bulb will close, right? Here actually the bulb is glowing. All of you remember this point. All of you you have to remember uh, here when the current sends automatically the filament glows continuous, that no problem. Sure, when these radiations will falls on this, that means the radiation temperature and this filament temperature both are equal, then the filament disappears. It will appears like this. Then we have to understand here the temperature of the body is matched. So for that, whatever the current you adjusted, that current is calibrated in terms of the temperature of the body. Now you got the point. Is this device an application of a pyrometer? Yes, lateral entry 45. It's an application. In our college, daily check the temperature of the person. No, 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 no. Optical here. Uh, yes, you are Mr. Lateral entry 45. So I will tell you next another number 39 lateral entry. Number 39 PMCC. I told you that it is a permanent magnet coil. It is a coil meter. It is another words we can also call it as a multimeter. It indicates the voltmeter or ammeter. That means current. It measures the current. This indicates here whenever the rheostat adjusts, then here the in the meter the current varies. Now you got a PMCC. What is the PMCC mean? Other words, simply you can write down ammeter, no problem here. In the place of PMCC, write down ammeter. Yeah, ammeter. PMCC means it is a permanent uh, magnet coil. It is a permanent magnet coil. PMC. Right. One person asked how the temperature is measured. Now you got the point, Mister. How to temperature is measured. You got the point. Any question? Any question? Any question? Any question? Number 39 lateral entry. I told you that how to temperature is measured. Whether you got it or not. Here, see here, current is passing through the filament is exact. That means here when the current is passing through the filament, the light glows, obviously. There is no doubt at all. Here, when the radiations, the body emitting radiations falls on the filament, this filament will disappear. What is the meaning of that means here both are coinciding, both are coinciding. So at that particular current, the filament disappearing means it is coinciding with the radiation temperature, radiation emitting body temperature. So now whenever the filament disappears, then at that particular current we have to measure with the help of the PMCC. That current is calibrated in terms of the temperature of the body. For example, if it is dark means that is here with the help of the eyepiece you are seeing. So it is not matching. It is not matching. It is wrong. So we have to adjust the rheostat in such a way that till the filament disappears. The meaning of the filament disappears means both radiations are matching. Both radiations are here. The filament is emitting radiation as well as the body emitting radiations. So both radiations are focusing, then the filament disappears. Then we have to understand it is coinciding, then at that particular current, we have to calibrate, we have to find out with the help of the meter, and then it will display. Then we can go for calibration at that particular temperature, at that particular current. This is the temperature. Current is measured, right? Is values are shown in numbers? Yes, numbers, numerical, right? We can go for analog or a digital meter. We can go for analog or digital meter. And then next, another one person asked here. Uh, so here the temperature in this device and application of, right, correct, Mr. Next we are going to discussing about that pyrometer only. Here, whenever the radiations it is focused on the object, what happens means it receives or every human body emitting infrared radiations. Every human body emitting with some infrared radiation having some wavelengths. That wavelengths is observed. So in our college, so one person written in our college daily check the temperature of the person. Is this device is an application of pyrometer? Yes, correct, pyrometer. That is infrared pyrometer. Next we are going to discussing about that one. Okay, sir, I understand. Please the volume, sir. Please, one person asked the 359 volume, sir. So whether it is audible or not, I'm speaking. Okay. Next, we'll go for the next one. Now you understand, right? About the optical pyrometer, right? Here this is the actual description of what I said, all the things. Huh? So already I explained all the things. This is the procedure, the explanation procedure, optical pyrometer. Next we'll go for infrared parameter. Sir, what this is the thing, Mr. One person asked that about, right? One person, the 45 lateral entry. So here in this infrared pyrometer, it is here every material, what I said to you, every material or every object or every body or every substance, it emits radiations, and that radiations having a temperature above absolute zero. Compulsory, it emits infrared radiations. Every body every body then only we are saying that the wall is in blue color, the wall is in white color, and my specs is in colorless, this is colorless, and this is some blue color or a black color, like that. So why I am, in which way I'm saying, that means every object or every substance, every body, every material, and whatever the thing on the universe, it is emitting radiations. If the emitting radiations means it is having a temperature which is above absolute zero, and it emits some wavelengths of infrared radiations, that we can also call infrared emitting. See here, it emitting infrared radiations depending on the temperature. So that means this is what the person said, the lateral entry 45. Here, when the focused, when here this is displaying device. In that displaying device, the temperature will indicates. Here, this infrared pyrometer is used in generally in industry purposes to measure, for example, water is boiling, oil is boiling. It's very too hot. For example, if I dip the water, okay, no problem, I will dip some water, okay, it is too hot. If it is oil, means it's very too hot. What happens? It will creates problem to my finger. So at that time, just I have to switch on this. It's like a gun. It's switch on this one, then automatically the radiation falls on that. It absorbs. It absorbs. What happens? It absorbs the infrared radiations emitting from that substance, and then with the help of the detector. Detector here means here we are arranging a detector. Detector is nothing but a temperature measurement device. Inside, we are incorporating a temperature measurement device that is nothing but a thermopile or a thermocouple. That the indicates the temperature of that body. It's a sensing device. Yes, absolutely right. It's a sensing device. Detector means it detects the variable from the environment. It absorbs the variable from the environment. So for example, in industries, if it's very too hot, it's a, so just to we have to click on that radiation to falls on. See here, if you observe clearly, This is a lens. From this lens here, if you see this arrow mark here, light is focusing on this target. Similarly, when it is focusing, if you see this here, it is mentioned arrow mark clearly, right? Here, from that radio infrared parameter, when you press, automatically the radiations falls on the body or a substance whose temperature has to be measured. And then from that, it is hot, or we have to measure the temperature. And this here, it absorbs the radiation. That means this detector absorb inside the detector, it absorbs the radiation. For example, here one radiation falls on this point. Yet from this particular point, what happens means this detector absorbs the radiations of that particular limited only. That point boundary only, it will absorbs the radiations. And then here detector means it senses or it detects the variable from this target. Here we can say target. Here, for example, here I place here the light. Only this is the targeted body. Only one hole, right? The radiations falls on that body automatically. From the targeted body only, whatever the radiations emitting is absorbed by the detector, which is in the inside of the pyrometer. So what happens? That radiations falls on the detector, and thereby the heat develops some heat. That heat is calibrated in terms of the temperature, which is displayed in the device. That is the thing. It is very simple. So what you see in daily are invisible to the human eye. See here, right? Infrared rays are invisible to the human eye and can be sensed, right? As heat. This is a heat here. Heat is developed. That means infrared ray having some heat. Maybe it is having some particular temperature, and that have longer wavelengths. That visible lights are known as infrared radiations, right? So these radiations possess less energy and less harm. That means it's a less harmful. It's in other words harmfulness, right? You can understand this one now. Shall I go to the next topic? Any questions you can ask? Any questions? You understand? Any questions? You can ask. Any questions you can ask? Okay, right. Very good. Lateral 345. Any other? Or you understand? Here, lens means normal lens. That means it will absorb like a glass lens. It will absorb the radiations, right? Here, this lens falls on that lens, and then here the detector absorbs that one. Next, any other? Okay, next we will go for the next step. Whether you are there or not, simply you are putting on the mobile or some laptop, and then you are going somewhere. So just I will check. I will ask one person. Number 56. 56 ఉన్నాడమ్మా 56 56 were there or not? 56 56 అమ్మా 56 లేడనమాట అయితే 56 is not there. Then అమ్మా this is not correct అమ్మా. Here lateral into 56 is there? Lateral into 56. Lateral into 56. Lateral into 56. Lateral into 56 కూడా లేడు. Here, this is not correct. And number 305, regular 305, regular 305, regular 305, regular 305. Mohan Kumar. Later, and I am not asking about 324. I am asking about 305. Regular 305, 306, 307. Regular 305, 306, 307. The next 20 regular, 20 regular, 20 regular. Okay, good. And number 23 regular, 23 regular, 23, 23 regular. ಏನು ಕೊಡ್ಲೇಟ್ 23 ಕೊಡ್ಲೇಟ್ 44, 44, 44, 44. Right. Here 23 is also not there. Actually, he is there. This is not good. The way of listening the classes, this is not the procedure. This is we arranged for you. But here, what you are having work? Just you have to listen the classes. It's enough over. Your duty is to study. That's it. But you are not doing. 23. Put palakada 23. Number 25. Regular 25. Regular 25. Regular 25. Right. Okay. Whether you are understand or not. Regular 25. 25. You understand or not? 28. 28. Okay. 28. 28. And what is it not? Number 28. Right. Okay. So next we'll go for the next topic. So applications of pyrometers. See, just overall applications it is, right? Here pyrometers, these are used in different applications, wide range of applications to measure the temperature of any objects. It is used, that means it is a non-contacting type device. It is a non-contacting type device. It is a non-contacting type device. Measures the temperature of a moving objects or constant objects from a greater distance. That means, so that's why I told you that it is a non-contact type of distance. From the with some distance also we can measure the temperature of a body whose that means it is emitting radiations body. And in metallurgical industries, to find out the temperature of the material, maybe hot material. And smelting industries, hot air balloons to measure the heat uh, at the top of the balloon. And steam boilers, what I said to you, boilers. Here in the boilers, it's a very somewhat difficult to measure the temperature and to measure the steam temperature also. To measure the temperature of liquid metals, the metals which are in the liquid state, it's very too hot, maybe 1500 degrees centigrade or 2000 degrees centigrade. So we can measure. We can also measure the furnace temperature, right? So these are the applications with the help of the pyrometer. So we can measure all these. We can measure the temperatures, right? Next, we go for the pressure measurement devices. Pressure measurement devices. Here in this, all of you know that pressure, you know very well the principle of the pressure. Anybody can go for 2 or 3 words sentences. Pressure. So first pressure measurement device. Anybody? First pressure measurement device. First pressure measurement device. So one person asked for smelting industry. Okay, right. I will tell you. Pressure measurement device. Pressure. Right. Barometer is the first device which is used to measure the pressure through calculation. All of you know that pressure is nothing but a force per unit area, right? Right. This is we can measure maybe the variable which is in flow or in level. That means when the flow means when the flow of fluid means there the pressure varies, and in the level also here there the pressure changes, and in the pressure it will plays a major role in determining the boiling points of liquid. That means the pressure vary. That means pressure varies means automatically the temperature varies. Here the both pressure and temperature both are related. Here when the pressure rises means what is the meaning of the pressure rises? The temperature rises, right? And fluid exerts a pressure on the containing vessel equally and in all directions. Right. Here these example. See here manometers. Here manometer. How can you measure the manometer? The pressure mg p is equal to mg h1 minus h2. That means h1 minus h2 is nothing but here the difference in heights in the limbs of the left limb and the right limb. Left limb we can say h1 and right limb we can call it as a h2. Then the difference of the limbs of heights into the product of mg, that means mg into h1 minus h2, that is nothing but pressure, the manometers. And you know very well YouTube manometers, right? There are so many manometers are there which is used to measure the pressure through mathematical calculations. But here in this in the pressure measurement in our syllabus, 3 or 4 are there. One is a dead weight pressure gauge. Another one is second one is diaphragm Bourdon, that means Bourdon tube gauge. Next diaphragm gauge. Another one is bellows gauge. These four we can complete. Then this pressure measurement devices, and then after that we have to go for the low pressure measurement devices. Totally 5 or 6 devices we'll discuss in the next coming class. Today's class we are going to discussing with dead weight pressure gauge. In the dead weight pressure gauge, or we can also call it as a dead weight tester. And another one is a Bourdon tube pressure gauge. Another one is a bellows gauge. Another one is a diaphragm gauge. So these are all four are which is used to measure the pressure. So in this dead weight pressure gauge, if you observe, see here, this is usually actually for the calibration of the pressure gauge. Can go for this dead weight tester is used for the calibration of a pressure gauge. Calibration. We have to go for a calibration of the pressure gauge with the help of this tester only. So here, first, this is nothing but a test gauge. This is a pressure gauge. Actual first, we do not place it this one. Do not place it first this one. In the first experimental, it is not there. Test gauge. Remember this point. Then here, it consists of weights, right? It consists of weights, right? And it's one platform and cylinder and piston is there. This is a piston and this is a cylinder. This is cylinder, right? This is cylinder, right? And this is cylinder, and inside some oil or a fluid is there. Here, the other side, a plunger is there. Firstly, this test gauge is not there. It is not attached to the tester. See here, when the weights is placed on the platform, what happens? the piston will press. That means will compress in the fluid. And then same similarly, this plunger, we have to push it. We have to push the plunger. Then automatically what happens, the pressure created inside the oil, thereby what happens means it push the piston and it floats in between these two limit stops. This float between the two limit stops. Here these are the limit stops. So again I'm explaining, all of you listen carefully. Here first, this test gauge is not there. Test gauge is not there. And then it consists of a platform. On that platform we are placing some dead weights. And then here the piston will move forward, which compresses on the oil which is placed inside the container. And then here a cylinder, right? This is cylinder. And plunger, right? Here when the weights placed on that top, what happens, the piston drops down, thereby the pressure creates, correct, inside the oil. So once the pressure create, it moves up, right? It moves up. Now we have to with the help of this handle, you have to press the plunger, and it will move forward. Thereby what happens means, inside the pressure creates more, and thereby this piston, it will float. So this piston will move top, and thereby it will floats on the between the two limit stops. So then we have to stop that experiment. And then with the help of this formula, you can go for calculation of pressure, how much amount of pressure is created inside the oil. So where P is the pressure and M is nothing but the mass of weights we have to place on the platform. And G, acceleration due to gravity, and friction drag. That means the friction between the piston and that cylinder, right? And A is the equivalent area of a piston and a cylinder combination. That means A is nothing but equivalent area of piston and cylinder in terms of meter square. So with the help of this known, we can find out the value of the pressure. We can find out the value of the pressure. So now after calculation of the pressure with the help of the formula, now you have to go place a test gauge. Now you have to place a test gauge, that is a pressure gauge. You have to place a pressure gauge. So now same procedure we have to check. Same procedure, same where weights are added on the platform, thereby this piston drops down. And similarly with the help of this handle, we have to push the oil, thereby the inside the pressure creates the oil, thereby the piston will floats in between the limit stops. We have to stop there. Here the piston will floats between the limit stops, there we have to stop. And then we have to find out the pressure which is indicated in this test case, this with the help of the indicator. This pressure and whatever you calculated, this pressure must be equal. Must be equal. For example, if it is not equal means just with the help of that regulator, we have to adjust it, and then we have to make it equal. So this is the calibration procedure. If it is equal to that calculation, then what we have to say, that test gauge, that is a pressure gauge, we are testing, we are placing on that one end. Then we can say the gauge is giving a correct reading, right? So this is for calibration. If it is not giving the calculator some errors are there means, we have to make it adjust. We have to make we have to set it to that pressure value. Now you got the point, right? Dead weight pressure gauge, right? Dead weight pressure gauge. Now you got it. Got it. Dead weight pressure. Any questions? Now I will take the attendance. You can respond one by one. Understand or not? This dead weight pressure gauge. Number 39. Lateral entry. Understand? Okay, right. Very good. It's very simple. First, with here the test gauge, we are not placing this test gauge. Test gauge means, what is the meaning of test gauge? That pressure gauge, we are testing whether it is showing a correct reading of pressure or not. So firstly, we have to measure the pressure with the help of this formula, and after that we have to follow the same experiment analysis. That gauge we are going to test, that will shows the same reading, then we can say the gauge is working correctly. If it is shows some error, it will not match to the theoretical pressure value, then again we have to go for some adjustment to make it correct. Number 301. 320 amma, 320. 320. All right. 18th by 320. I'm asking about 18th by 320. 381. 18th by 381. Absent. 18th by 381 absent. 18th batch 381. I'm asking. Right. Okay. Okay. 320 is also present. Next one, number one. 3, 2, 3, 2. Number two. 3, 4, 3, 5, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, right? 15, 16, 16, okay, 17, 307, okay, 17, 18, 18, amma, 18, I'm asking 18. 18 వచ్చాడా? 18, 19 present, okay, 18, 19, 18, 19, 20, 21, 22, 22, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 35, 35, 28, okay, 35, 35, 35 option, 36, okay, 37, 38, 39, 37 present, okay, 38, 39, 40, 30 present, okay, 40, 41, 43, 43, 43, 43 option, 43, 44, 45, 46, 47, 48, 49, 50, 51, 51, 52, 53, 54, 53, 53, 55, 50, 53, 54, 53, 54, 55, 56, 57, okay, right, right. 60, 61, right, 61, right, right. Lateral entry 1, 2, 3, lateral entry 1, 2, 2, 2, 3, 4, 5, 5, 6, 7, 6, 7, 6 option, 7, 8, 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 15, 16, 16, 16 option, science, okay, 17, 18, 19, 19, 19. I'm asking about 19. Lateral entry 19, 20, right, 21, 22, 23, 24, 25, 22, 22, lateral entry 22, 24, 25, 26, 26, 27, 28, 29, 28, 29, 30, 31, 31, 32, 33, 34, 34, 35, 34 option, 35, 36, 37, 37, 38, 39, 40, 41, 42, 43, 43, 44, 45, 46, 47, 46 option, 46 were present, 47, 48, 49, 50, 51, 52, 52, 53, 52, 53 lateral entry, 52 option, 54, 55, 56, 56, 57, 57, 56, 57, right, okay. Here the absent is regular 1, 2, 10, 18, 22, 35, 54, 3, lateral entry 3, 6, 19, 22, 31, 34, 52. Lateral entry. 58 present, regular lateral entry 2 present, right? And 33 present, 46 lateral entry present, right? 353 present, lateral entry 24 present, oh, correct. 301 lateral entry present, regular 310 present. Lateral entry 355 present, okay. The lateral entry, the absent is lateral entry is 3, 6, 19, 22, 31, 22, 31, 34, 52. These are absentees, lateral entries. And the regular 1, 2, 18, 22, 35, 54 absent. Okay, 24 present, right? Okay, thank you all of you.